Welcome. This video is for lesson 9.4a for Expo. We're going to look at factoring to solve quadratics. So now we've gone through a few methods with square roots and graphing. So now we're going to go back and look at factoring again, which is what we did last chapter. So hopefully we can remember some of those things and do a good job with it. Starts with some review again. So the first thing that they're looking to review is again that opening up and down with the graphs, and then answering some questions about A and C. So for this one, A is -1/4. Okay, that number controls two things. It controls if it opens up or down. When it's negative, it opens down, and then it controls if it's wider, narrower, or the same width as x squared. Okay, anytime it was a fraction between 0 and 1 was when we had our answer be wider. The -2, that's called the C term. That moves the entire graph down 2 units. So it takes the entire graph and shifts it vertically down 2. Next is review of the word problem. We keep looking at the same word problem over and over. So it's the same two questions to begin with. A soccer ball is kicked into the air with an upward velocity of 22 feet per second. Its height after t seconds is given by this function. So what we need is the A term, the B term. Okay, that's going to help us with parts A and B. The C term doesn't really come into play until we plug it in part B. So when will the ball reach its highest point? That's just opposite of B over 2A, like we've been practicing. Okay, that's the formula for the axis of symmetry. That's going to be how many seconds until the ball is at the top of its path. We're interested in this point right here. How many seconds until it's there? So that's going to be the opposite of 22, so -22 over 2 times -16. So we have -22 over -32. The two negatives are going to cancel each other out. So we're looking at 0.6875 seconds. Okay, we usually don't round on this step. Okay, this step, just keep the whole answer. Now for part B, we're plugging it in. So we're finding the height at 0.6875 seconds, which is going to be -16 times 0.6875 squared plus 22 times 0.6875 plus 1. All right, so maybe you can do it one at a time. The -16 times 0.6875 squared gives you -7.5625. Again, I haven't rounded anything yet. The 22 times 0.6875 is 15.125. And then plus 1. So if we add all that stuff up, we end up getting 8.5625. Okay, I still haven't rounded, but that's how many feet it would be in the air at that point. All right, so just taking a look at what that maximum would be. All right, so then moving on, okay, what we're looking for today is how to solve by factoring. So the zero product property here, okay, is going to be an important idea. So looking at zero product property, okay, the first thing I would say is if we have sum A times B equals 0, okay, the only way that that's true, A times B equals 0, is if A equals 0 or B equals 0. So if two things are multiplying to 0, that means that one of them have to be 0. So going back to the example that they gave in the notes, if it's x plus 2 and 2x minus 5, okay, either x plus 2 equals 0 or 2x minus 5 equals 0. So that's what's happening in this situation. So either this piece is 0 or that piece is 0. So what that ends up allowing us to do is it allows us to solve for x, because if x plus 2 equals 0, then that would just mean when you subtract 2 from both sides that x equals -2. If 2x minus 5 equals 0, then we can add 5 to both sides and then divide by 2. So x would be 5 over 2 or 2.5. So those are going to be the two equations that would make the whole thing 0. And remember, that's what we're trying to do when we solve these quadratics. So what we're going to be looking at doing is eventually factoring to get our answers here. Okay, these ones right here are already factored. It just says use the zero product property. So everything's already factored for us. We just need to be able to get that answer at the end. So if we have 4t plus 1 times t minus 2 equals 0, all we need to do to use the zero product property is split it off. We know that 4t plus 1 equals 0, or t minus 2 equals 0. Okay, so there is going to end up being two solutions to this situation. To solve the one on the left, we would have to subtract 1 from both sides, just our normal linear solving skills. 4t is now equal to -1. Divide that by 4, so t is equal to -0.25. Okay, that's one of our solutions. The other solution is if t minus 2 equals 0. All we need to do to solve that one is add 2 to both sides, and that would give us an answer of t equals +2. All right, and then we can keep going. They don't change a lot from there. Okay, if you have two things, 1, 2, that multiply to 0, then either the first one is 0 or the second one is 0. So the one on the left solves in one step. Divide both sides by 4, but 0 divided by 4 is still 0. So one of the solutions to the entire equation is 0. The other one is subtracting 1 first. Whatever you do to one side of the equal sign, you got to do to the other. And then dividing by 5 next. So this one is -1/5. You could just leave it like that. Or you could do -0.2 if you wanted to give a decimal. Okay, and then one more time. So if x plus 1 times 3x minus 5 equals 0, either x plus 1 equals 0 or 3x minus 5 equals 0. The first one is just one step again. Subtract 1 from both sides. You get x equals -1. That's one of our solutions. Or 3x minus 5. We would have to add 5 over first. 3x equals +5, and then divide by 3. So x is 1.6 repeating, so I will just call it 1.67. Okay, so what I'm showing you right now, this is actually the last step on most of these, because what all of these are called, okay, are factored form. All of these three examples have been in factored form. So the thing is, we might have to get it into that form first. So the way that we got things into two parentheses was factor. So to solve by factoring, we might have to factor first. So that's going to be the difference on the next example. So in order to get the equation in a form to use the zero product property, you need to first factor. So that's going to be something that I hope we remember okay from last chapter. So that's something that we worked on a lot, and this is kind of the reason that we did so. So I can't use zero product property on this first one, x squared plus 8x plus 15, yet, because I don't have it written as a product. It needs to be written as a product. I need to get it into two parentheses. This is the form that I want everything to look like so that I can solve with algebra like I was just doing. All right, so let's see if we remember this. So what we were looking at, we want to turn this into two parentheses equal to 0. That's what we want to do first. So in order to do that, we have to look at the signs first. If everything is positive, then we use 2 plus signs. We look at the front term. If there's no number in front of the front term, we just broke it up into x times x. And then we looked at the factors of 15, and we selected the factors of 15 that multiply to 15 and add to 8. So 3 times 5 is 15, but 3 plus 5 is 8. So we would put a 3 and a 5. When it was a plus problem, it didn't matter which one was which. Okay, so this is where we stopped before. We factored it, and then we moved on. Now we take an additional step of solving it. Okay, so now we solve. Okay, So that could be x plus 3 equal to 0 or x plus 5 equal to 0. So here's how we're going to find our two solutions. This one we would have to subtract 3 from both sides, and we get x equals negative 3 as one of our solutions. Here we would have to subtract 5 from both sides, x equals negative 5. So now we factor and then we solve by factoring. What we just found are the two x-intercepts if we would graph it. So we're doing factoring now because these ones wouldn't be able to be solved by square roots like we were working on in the last lesson. Okay, let's do another one. So this one, we want to factor it first. All right, when we have only the middle term is negative, okay, that means we want to still multiply to a positive, so we would use double negative for this one. Okay, we want to find two numbers that multiply to 14 that add to 9, and that would be the 2 and the 7. Since we have two minus signs, it doesn't matter which one gets the 2 and which one gets the 7. Okay, now to solve it, we just split it up. M minus 2 could be equal to 0, or M minus 7 could be equal to 0. If I have two things that multiply to 0, one of them has got to be 0. So if I add 2 to both sides, one of my solutions is 2. If I add 7 to both sides of the second one, my other solution is 7. We keep them both. Okay, there's two good answers for these. Okay, let's keep going with the examples. So with p squared plus p minus 20, okay, we're looking at a negative final term, and this is like a 1. So we're trying to multiply to negative 20 and add to positive 1. Okay, so anytime that last number was negative, we automatically put one plus and one minus sign. That was an automatic each time. So now the strategy changed a little bit when we're looking at the factors. Sorry, bad handwriting, but 2 times 10. If we're looking at the factors of 20, now we're looking at the one, none of those add to 1, but these ones right here are 1 apart. So when you're trying to get negative 20, we're going to use 4 and 5. What we did is we said if the middle number was positive, then the big number got the plus, and the little number got the minus. So we're going to try putting 5 here and 4 here. Okay, remember you could always check your work, but this is the correct factoring of this one. So p plus 5 and p minus 4, each of those need to get set equal to 0. Okay, all we need to do to solve the first one is subtract 5 from both sides. So negative 5 is one of the answers for p. And then in the second one, we would just have to add 4 to both sides. So positive 4 is the answer for the second one. Okay, and then they just get some variations. It gets tougher as we go toward the bottom here. Okay, these three at the bottom are a little bit tougher because they have a number in front of the squared term. This first one, okay, you just have to realize it's a GCF. Okay, this is a GCF problem because it's only a binomial, so that's your first hint, and there isn't a C term. So there's no C term that we can look at. So the only other thing that was a binomial was a difference of squares, but 8 is not a perfect square. All I would look to do is take out a GCF here. So the GCF is x. Both of those terms have an x in it. So what I can do is I can divide both of these by an x. I can put the x out front. All right, x squared divided by x is x, plus these x's are going to cancel, so all I will have left is an 8. And then I can still solve that because I still have something times something equals 0. This one ends up kind of easy. One of my answers right away is x equals 0. Okay, this one I have to set equal to 0 and then solve, but that's just one step of subtracting the 8 to the other side. So x equals 0 is one answer, and x equals negative 8 is my other answer. So sometimes it's just a GCF. All right, let's move on to the tougher factoring. So sometimes there's a number out front. What that does is now you have to look at the numbers that make 6 along with the numbers that make 2. Okay, the good news for this one I'm just going to give myself more space, but the good news for this one is we have positive, positive again. So that's good. Okay, now I know that I have to use 1 and 2 by the plus sign. That's the only way I can multiply to positive 2. So then it's just trying to figure out how I'm going to make 7. So something in this list on the left has to get doubled. If I look at doing 2 times 2, that'll give me 4, and then 4 and 3 will add to 7. So I want to have a 2x here and a 3x right here. Remember, it's probably a good idea to check that. So these two give you 3x's, these two give you 4x's, and that gives me the 7x's that I wanted. All right, that's not a bad idea when you're factoring like this to check those answers. Okay, so we still have to finish by solving. So we have to set 2x plus 1 equal to 0, and we have to set 3x plus 2 equal to 0. We have to solve both of those. So they both take 2 steps. The first step, I would have to subtract the 1 to the other side, and then I need to divide by 2. So for this one, x is negative 1/2. Okay, for this one, I would have to subtract 2 to the other side, and then divide by 3. So this one is negative 2/3. Okay, so when you factor, you're looking for 2 answers. Okay, we have 2 left, so let's give them a shot. We have out here, we have to worry about how to multiply to 2, but there's only one way to do that. We're just going to split that into 2 times 1. 18, we can do 1 times 18, we can do 2 times 9, or we can do 3 times 6. So when I set this up to factor, I want to first check the signs. Only the middle is negative, so that's a minus minus. I'm going to just go ahead and throw 2a and 1a into the equations because that's my only choice out front. Now I just have to figure out how to get to 15, and that's just going to be doubling one of these numbers. Okay, if I double one of these numbers, then I can get to 15, a in the middle, right? So the one that I want to double is the 6. If I double the 6, and then I put a 3 here. The reason that works, these two make negative 3a, these two make negative 12a, and negative 3 and negative 12 make negative 15. Okay, so the ones with the numbers out front were the harder ones to factor, but they'll come back to with practice. This is equal to 0, so we have to split and solve both of these. Okay, this one works out kind of nice on the right. All I need to do is add 6 over. One of my answers is a equals positive 6. This one I have to add 3 to both sides first, and then divide by 2. So the other answer is a equals 1.5 or 3 over 2, however you want to write that. Okay, this time they're both positive. All right, one last one. So, and then I'll have you work on the assignment with the rest of the time. So this last one, okay, looking at our choices, we can either do 4 times 1 or we can do 2 times 2. For 18, it's the same choices we just had. 1 times 18, 2 times 9, or 3 times 6. All right, this time it's a positive and a negative, so this is the hardest version of factoring right here. So we're trying to find a way to get to 21. Okay, so you want to figure out how you can get in that ballpark. The way that you want to do this one is you want to use the 4x and the 1x, and I'll show you what my reasoning is in a second. But if I can do 4 times 6, and I can make it a negative 6, then that gets me all the way to negative 24. Then I just have a positive 3, and that's going to be exactly what I want for this one. So let me show you why what I did worked. This is a positive 3x. And this is a negative 24x. Together, those add to negative 21x. Okay, so again, what's different now with factoring is that's not the answer. Okay, there's 2 answers now when you factor. So now we're solving by factoring. So we have to set 4x plus 3 equal to 0, and we have to set x minus 6 equal to 0. Again, this one goes pretty quickly when you add 6 to both sides. Okay, this one you would have to subtract a 3 over. I'm not showing all of my work. and then divide a 4 over. Okay, negative 3 over 4 is fine, or you could do negative 0.75 if you want. Okay, so it kind of depends. If you remember your factoring really well, this will probably go really well. If you need to brush up on it, then that's exactly what we're here to work on and get better at. So tomorrow we'll do more of the same and we'll go from there. Thanks for watching, and let's try the assignment now.